Our group was tasked with finding the relationship between hospital spending and quality of care to see if we could optimize a hospital's performance. We were given a data set of 4,500 U.S. hospitals. First, we identified three features that helped explain variance in Medicare spending per patient, or MSPB: emergency services, hospital ownership type, and state. Hospitals with emergency services spent significantly more per patient than hospitals without. Government-owned hospitals spent less per patient than nonprofit and privately owned hospitals. The state with the highest spending here are highlighted in dark blue. We've also ranked states according to quality and spending and highlighted the most inefficient states here in dark red. Our second task was to group the hospitals according to quality. Of 36 quality variables, we've chosen 6: death rate, rate for collapsed lung, blood clots, wound that splits open after surgery, accidental cuts during surgery, and serious complications rate. We've eliminated a redundant variable, serious complications, using feature selection. We've also ran principal components analysis, however, did not result in further reduction. Using these 5 quality metrics, we've identified 3 categories using hierarchical clustering. The first cluster is high performers, hospitals that performed well across all quality metrics. The second cluster is poor performers. These hospitals had a 65% higher rate of accidental cuts and tears than the high performers and a 40% higher rate of lung collapses. The third cluster is the poor wound care cluster. These hospitals had a tremendously higher rate of wound that splits open after surgery, which is 165% higher than that of cluster 1. The poor performers cluster number 2 is spending significantly lower than the other 2 clusters. Government-owned hospitals were also significantly overrepresented in this poor performers cluster, as were hospitals in smaller states with less than 30 hospitals. To analyze the relationship between quality and spending, we used linear regression and random forests. We looked at spending as a function of the 5 quality inputs, as well as state, hospital ownership, and emergency services. In linear regression, state, ownership, and emergency services were all statistically significant, along with accidental cuts, blood clots, and lung. However, the error rate was high at 44%. In random forests, state was also the most important variable in reducing mean standard error, followed by accidental cuts and hospital ownership. Random forests also had a high error rate of 38%. Since both models had high error levels, it means the models didn't really fit the data. Therefore, we don't have enough evidence to prove that quality is related to spending. Now, classification has some success in predicting whether spending was above or below the median using the same inputs. In this model, accidental cuts was statistically significant in predicting lower spending, and the accuracy rate was 75% for this model. While it was more accurate, this model is a little bit more risky because of the information lost from reducing the spending variable to a binary problem. Since accidental cuts is linked with lower spending in both classification and our clustering model, however, we've made the following state-specific strategies. 1. Focus on policy to improve the accidental cuts metric, particularly in Minnesota, Colorado, and Oregon. These states were overrepresented in the high accidental cuts cluster of poor performing hospitals. 2. Analyze wound care technology and techniques in certain New England states like Massachusetts, New Hampshire, and Maine. These states were overrepresented in the high wound incident cluster. 3. In order to continue our research, we'd like more microdata on quality to find out cause and effect relationships that happen during surgery so that we can target which specific metrics are the most important to focus on improving in order to have the highest net benefit on MSPB.